Oh. Okay, so we are looking at surface area and volume. Your notes explain that a prism is a polyhedron that has two parallel identical bases. The lateral faces are parallelograms. Does everyone have a highlighter?
No.
Does anyone have a highlighter?
I do.
Okay, you can use your colored pencil if you need to, but you're going to be like circling some stuff and underlining. Don't use a normal pencil because I want it to stand out. Yes, a color. Okay, I want you to underline prism. Okay, it has, what? It doesn't matter with what, yeah, just a color. Okay. It has two parallel identical bases. So you can see here, we have this side, we have a base right here, and a base on the other side. Then it has its three lateral faces that are parallelograms when it's a triangular prism. Pyramid, you can see it comes to the point at the top, Mason. It comes to the point, which makes it a pyramid, and it has one base, and the lateral faces are triangles. Okay? So even if the base is a triangle, the lateral faces are still going to be triangles as well. Okay? I want you to underline or highlight the shape of the base tells the name of the prism or the pyramid. Okay, pyramids only have one base, and they come to the point. Prisms have two bases that form lateral faces that are parallelograms. Of these three, which ones are prisms? Is this one a prism? Dalton?
Yes.
Yes, so we're going to circle it. How'd you know it was a prism?
Because the base is a triangle.
Well, that doesn't necessarily make it a prism.
Because like when it unfolds, kind of.
What makes a prism, Lindy?
They have identical bases or like whatever.
It has two identical bases, so it has the top and the bottom. They are both triangle bases. So what's the name of this one? What kind of prism is it, Cameron?
A triangular prism.
Good. So I want you to write that on the line. Triangular prism. What about this one in the middle? Is this raise your hand if you think it's a prism. Raise your hand if you think it's a pyramid. Good. It is a prism. So go ahead and circle it. What's this one going to be called? What kind of prism is it, Layton?
Rectangular prism.
Good. A rectangular prism. And then what about this last one? Raise your hand if you think it's a prism. Raise your hand if you think it's a pyramid. Does it come to one point? No, it's a prism. All three of these are prisms. So what is this one called? Cameron.
Triangular prism again.
Good. It is a triangular prism again. Okay, so the first and the third one are the exact same. We're just seeing a different view. One of them is vertical and one of them is horizontal. Okay. What about these pyramids or these pyramids? Is this first one a pyramid?
No.
Raise your hand if you think it is. Raise your hand if you think it is not. It is a pyramid. So go ahead and circle it because it comes to a point, right? It has one base. It has triangles coming up. Okay. So what is this one called? Cameron?
Triangular pyramid.
Okay. Triangular pyramid.
Didn't we just say it's a prism?
No, it is a pyramid. That's why we circled it.
Oh.
Okay. What about this second one? Raise your hand if you think it is a pyramid. Good. Dayton, why do you think it's a pyramid? Because it all comes to one point and it has one base. What do you think the name of this one is? Jersey? Okay. What else do we think? Dallas? Square pyramid. Technically, you could use either because we're not sure if it's a square or a rectangle, but we're going to use square for this purpose. Okay, so this is a square pyramid. Well, rectangles have 4 sides. Yes.
On that left side, is that
This one?
pyramid? Is that a PYR?
All of them are PYRAMID. Yes. What about this one? Raise your hand if you think it is a pyramid. Raise your hand if you think it is not. Good, it is not. So I'm going to put an X over it because it is not a pyramid. But we still want to name it. So what would this be called, Dayton? Good. It is a rectangular prism. Any questions on that? Layton, did you name that one? Put an X over it. Rectangular prism. Yes, Cameron.
Are these notes going to be our homework? Or
No, this is not your homework. There is, but it is very simple. Okay, flip your page over. This is just an information sheet. This is showing you, I want you to highlight some stuff though, or underline. Surface area is the sum of all the areas of all of its faces. So you get the area of every single base or face, and then you add them all together. Okay, the sum of all the areas of all of its faces. Okay, we already went over a net a little bit. You can use a two-dimensional representation of a solid called a net. Go ahead and circle net to find the surface area. Okay, so down below, you can see this is a net of a rectangular prism. So it was a rectangular prism, and then they unfolded it, and this is what it would look like. Okay. Same with this one. This is a triangular prism. It has its 2 bases and then 3 sides. And you unfold it, and it looks like this, and it labels them for you. And then down at the bottom, you have your pyramids, what they would look like if you unfolded them. Yes, Dalton?
Well, is that rectangular prism, net of rectangular prism? Is that right? Because, wait, never mind.
Okay. Okay. And then up at the, we have volume, which is the product of the length, width, and height of a prism. So it's V equals length times width times height. You just multiply all 3 of those. Over on the right, we have your important formulas that you will be using, because we're going to need to know the area of the sides. So you're mainly going to be using square, triangle, some rectangles probably. Okay, and then on here, we have the perimeter at all sides. Highlight that, underline it, circle it, something. And then circle your volume. So volume, length times width times height. LWH. You need to remember that. Any questions? Okay, go ahead and put your notes to the side and get out the sheet that says Part A and Part B.